Welcome to my talk. My talk is called I Didn't Know You Could Do That with Java Streams. I hope you had a good lunch break today. And first, to introduce myself, my name is Francois Martin, and I'm a senior full-stack software engineer, and I come from Switzerland. And I'm also a streamer. Well, I stream on Java, so I don't know if you do too. And by the way, I work for Karakun that develops software for customers, and we also have offices in Switzerland, Germany, and I'm also an active member of the Swiss Testing Board, which is driving forward certifications in software testing. And I'm also a member of the ISTQB working group, which is called Advanced and Expert Level Working Group. And there I'm also an author of 2 syllabi that are coming soon. By the way, you may see that on the top right, there is a QR code. You can scan it to get the slides and to get the code that I'm about to show you later. It will be on the next couple of slides. When I'm showing the code, it won't be on there, but I will show it at the end again in case you missed the opportunity, just so you know. So to start out, I know when you learn something new, you always tend to try to use it everywhere you can, just because you feel like, that's such a cool feature. But I just wanted to preface this by saying, make sure you don't overuse streams as well, because streams are good, but of course, if, for example, you have a database where you're getting your data from, then you should always prefer to try to get it from the database first by just writing a query that does it for you. And then, of course, if you can't write a query that does what you want, or you need to transform the data anyways because you need it maybe in multiple representations that would be difficult to get from the database, this is something you can do. But just keep this in mind. Because a database lookup is still faster than using a stream, even though streams are very optimized. So just keep this in mind. This is really something that I see quite a lot in software projects that I've worked on in the past. I've always seen companies just pull all of the objects from the database, and then they just transform it this way. This may work when an app is small, but as soon as it grows a bit bigger, then it will be a bit more difficult to do that, of course. But usually, a lot of people, they don't think about when they just start out with a project what will happen or how it could scale in the future. So just make sure that you prefer to write a DB query, even if you think like, I won't have that many users, because usually it tends to be the case that you have more users than you think. So let me first have a quick survey here. So who of you knows how to code in Java? OK, so that's basically every one of you. In case someone of you didn't raise their hand and you're not familiar with Java, this may be a bit advanced for you, but feel free to leave if you feel like it's not the right thing for you. Let's start with this example here. Who of you understands what this code does? OK, so that's also most of you. This is kind of what I consider to be a basic Java stream. I have to say, in every code base that I've encountered, most of the streams had at least a filter or a map or something like that and a collect. And I feel like those are kind of the building blocks or the, let's say, foundational blocks that you have in streams. And so what we do here is we have here a list of products, which we start a stream from. And then here we filter out all of the products which have a category which is electronics. Then we get the name of all of the products. And then we just bundle everything that we get up into a list. And this is what we get as a result. So this is really a very basic example. And by the way, my goal is for every one of you to learn at least one new thing today. So as soon as you learn one thing, if you want, you can leave. It's fine. You don't have to stay for the full 50 minutes. Yeah, so let's start out, I would say. So I will go through the code. And I always have like a basic and an advanced example. A basic example is something that I found maybe in a code base, in some project that I was in, and that I, either, let's say, for example, submitted a comment on the pull request, and I was like, maybe we could change it to this to improve it, or, just in general, how you could write a code, for example, also without a stream, and then how you could turn it into a stream, depending on, what I saw in practice. So let's start out with find any and find first. this is something that I was kind of considering to be a bit basic, but I was surprised to see how many people don't know about this. So on the one hand, if you're already familiar with the concept of find any and find first, one mistake that I see being done a lot is that people tend to use find first a lot when it's not really necessary. So find any gives you just any object if you have multiple, and find first gives you really the first one. But usually I tend to find that find any or find first is mostly used in contexts where you only have one element to begin with, or where you expect to only have one element, or maybe you have two, but it doesn't really matter which one you pick. In those cases, find any is better because it has better performance. If you use find first, then by doing this, you're kind of... Oh, I noticed that it's not showing up on the slides. Let me see. Now, thanks for the hint. Yeah, great. Can you see the code, by the way? Is it big enough? Give me just thumbs up. OK, perfect. Thank you. Great. So again, find any here. And in most cases, I found that using find any is really good enough. Unless, of course, one example where it makes sense to use find first would be, for example, if you use sorted. So if you have a sorted stream and you want to have the first element in the list which is sorted, then this is preferable. And I remember I mentioned that the performance of find first is worse because it forces the stream to be essentially in order. While if you use find any, it could be that the stream can just process it out of order if it notices that, for example, this is a faster way of doing it. So this is a basic example of what I've seen in codebases a lot of times before. So you have so the challenge here is to find the primary address of a customer. By the way, I think most of the examples here that I did were relating to an online shop. So here we have a customer account. We get the addresses from the account. We get a stream from it. We then filter for any of the addresses that are primary. And again, here, you usually only have one primary address, right? So you basically would want to use find any here, because you don't need to make sure that it's the first one. And what I've seen being done a lot is to collect it to a list first, and then it looks if the list is empty. If yes, it defines null, else it gets the object which is at the index 0. And if you write this with a stream, where we use find any, then you can simply leave out the collect and replace it with find any. Find any is also a terminal operator, which is the same as a collect in this case, because it tends to finish a stream. And then we have an optional here, and we can use or else, for example, to get null, just to make it equivalent to this one. But of course, try to use something else than or else if you can, depending on your use case that you need to use it for. So you see, this is quite neat, and it's easier to read as well. I mean, here you could write this without the ternary, then it becomes a bit more readable, but then it becomes longer. So yeah, this approach really makes more sense. It's more readable, it's more explicit. So please, if you have cases like this, try to use find any or find first, depending on if it's sorted or not. But yeah, by using find any here, you really also get some performance benefits, because especially if you have a lot of elements in your list, if you have here a case, then it will filter it, and then it will collect it to a list, which means it needs to first gather all of the elements. While here with find any, it may make some optimizations where it will maybe just pull in a few of the elements or consider only a few of the elements, and then this will also be quicker. So this is also a performance advantage. So to get to the next one, maybe let's see, who of you knows any match, non-match, or all match? OK, also quite a lot of you. So that's nice to see. So those are all very, very similar. So any match tells you if there is any element that matches, non-match if there's no element that matches, and all match if all of the elements that you have match this condition. So here in this example, we want to check if any of the items are out of stock in our online shop. So we have our items here. We open a stream. We then filter it for the items that have a stock of 0, so that are out of stock. And again, what I see often being done is just to do collect just to list. And then people check, is it empty, and if it's not empty, we have some items that are out of stock. So we know, okay, it's out of stock. Then another variant that you can do, which is a bit better than this one, is to use count here, actually, where you will use count, and then you will get the amount of elements in this list, and you say it must be bigger than 0. And the better way to do this is to use AnyMatch in this case. So here you see it's also shorter. We can leave out the filter. We can just put here an AnyMatch, and then we say item get stock equals 0. So if we see any element that has a stock of 0, then it will tell you that it is out of stock. And again, this is better in terms of performance because as soon as it finds the first element that matches this condition, it will automatically return true. While in this approach or in these two approaches, you first need to go through all of the elements, to either count them or to collect them to a list, which is more expensive, of course. So here, really, it's nicer to read, it's shorter, and it has better performance. So why should you not use it this way? So let me see. Who of you knows flatmap? OK, also quite a few people. So you seem to be very advanced. That's great. So here, just to show you, this is an example where we want to check if a user has a permission that we require, for example. And here, we have 2 for loops that are nested inside of each other to get the roles and the permissions. Then we check, does the user have the permission? If yes, we return if this would be a function. And else we throw an access denied exception, for example. And the better way to do this, or this is probably arguable, especially in this case, because both are maybe somewhat similar in length. But maybe this is just my bias of liking streams so much. But yeah, so here what you can do is you do a flat map operation just to fill kind of the purpose of the inner for loop that you have here. So you see we have here role.permissions, get permissions. And here we have the same. But what we do is we call stream on here again to essentially flatten all of the elements that are in here into the stream. So what we are doing is, at this point, when we are executing this filter, we only have a list of the permissions here. We don't have a list of the roles, but we have a list of permissions of every role that we had here. And then you could, for example, filter it to see if there is a permission that equals this required permission that you're looking for. And then, again, find any is something that you could use to find out if this is the case. Or, of course, you could also use an AnyMatch here if you wanted. But if you use AnyMatch, then you can't use or else throw. This is just a preference of mine. I prefer to have it that way. There is this method, in case you don't know it, on optionals, which you can call to get to throw an exception, like here this access denied exception, for example. So then, this is one neat trick that you can do with flatmap as well, by the way. So maybe you've had a case before where you needed to where you had a list with optionals, and you needed to maybe just remove all of the elements that are empty. And traditionally, how you would do this is by instantiating here an array list, and then you would go through the optionals. If they are present, you add them to the results list. And by the way, this is an anti-pattern. So every time you see is present and get being used in this way, this is kind of not how you should do it in the first place. There are rare cases where you don't really have a chance to do it otherwise. But in most cases, there's a better way. And in this example, the better way to do it would be to use if present, which allows you to define a lambda where you can define the result and take the result and add it to the list. So this is already a better approach than this one. But there's an even cooler approach by doing it with streams. So you can see we can simply call flatmap here and say optional stream, and then collect it to a list. And that's it. And the big advantage here is as well, so if you want to do some some permutations, like, for example, you want to, you don't have a list here of strings, but maybe a list of objects, then you could just take each of the objects, and you could, for example, I don't know, get the name of them or something else. And this way, it's even easier to do than if you look at this code here. And especially the more things add up to it, the more readable it will become as well, compared to the traditional approach, I would say. Then let's go to collectors joining. Who of you is familiar with that one? Okay, so fewer, but still around half. So yeah, this is a good solution to a problem that probably every one of you has had in the past before. So you had to, for example, join the product categories by a comma and a space. And then, if you do this before Java 8, this is especially painful. You have to create a new string builder. Then you have to do a for loop. You have to add them. And you have to choose from a few different approaches. This is just one way of doing it by checking if this is the first element and then having a Boolean here. And then you set it and you append it to the string builder, append the delimiter, and so on. So this is really not something that is easy to read. And there's also another approach where you, for example, add them and then you cut off the comma and the space at the end, which is also a bit hacky in a way, or at least it feels bad in a way. Every time when you do this, it kind of feels wrong. And thankfully, Java 8, aside from introducing streams, introduced another function that is kind of useful, and this would be string.join. So what this allows you to do is to pass it a list of strings, for example, here, and then you can define a delimiter, and it will simply join them together, and it will ensure that there is no comma and a space, for example, at the end as well. So this is kind of useful. But of course, why should you collect the things here and then call it here? Why not, do it just with streams, which you can do with collectors.joining. So what you do is here, you kind of replace this collectors to list and this call that you see here, just with calling collectors joining. And you can see this is a really easy way of writing it, and it's also very readable. You instantly understand what happens here. You can see, okay, here it joins all of the product categories together using a comma and a space. And this is something that, compared especially to this example, is much more readable. I think every one of you would probably agree. So let's go to min and max. Who of you knows of those ones? OK, so most of you. That's great. So min and max is a feature that you can use to get either the smallest or the biggest element. And this doesn't have to be just strictly numbers. This can be dates as well, as I'm showing here. So for example, you could call sorted here and then say you're comparing the orders by their creation date, and then reversed to get the newest order first. And then, as I mentioned, this is one of the examples where find first does make sense to use. And then here you would get the newest order. And this is something you could do a bit better even by just doing max. And then you see we can also get rid of the sorted operation here. We just write whatever we have in the sorted here inside of here. And here we also don't have to write the reversed, because since we are using max, it's already obvious from the comparator which one it should use. So this also becomes even more readable, I would say, because here you need to remember, oh, well, sorted, and then reversed. Wait, how does that work again? It's the newest, right? And you're maybe second-guessing yourself, while here you see, OK, it's the max, so it's the highest state in a way, which is the newest one, of course. And then you just use comparator comparing, and you put here the thing you want to compare. And this makes it very easy to get the biggest element. Or you can also do this with min, with the smallest element. Then we have map to int, map to long, map to double, map to object. Those are probably ones that you are familiar with, just to recap it a little bit more. So let's say we want to create 5 order objects where we want to have the index in the name of a list. The way you would do this with just a for loop is you create an array list here, then you write a for loop, you add it to the list, you create a new order object, and we pass here in the constructor the name of the order, which is the order plus the number and a hashtag and the number. And then in the advanced example, we can do an instream.rangeClosed. I'm curious, how many of you knew that this exists? OK, so fewer of you. So that's already great. So this allows you to specify a range of numbers. There's range closed and range open, which either includes or excludes boundary values. And here, if you want to have numbers from 1 to 5, this is also a bit easier because here, this is kind of a bit of a trap, because usually we expect for loops to start with a 0 and then not have smaller equals. So if you don't look at this, which probably I would not look at it in in the first place when I look at code. This is a nice way because here it makes it more explicit. So here you can say I'm starting from 1, I go to 5, and then this kind of produces a stream for you which goes through all of the numbers from 1 to 5. You can call map to object, then create a new order here, and you can collect it to a list. And that's it. Essentially, this allows you, with map to object to get a stream of objects from a stream of ints. So as soon as we are on this point, we are still on a stream which is out of integers. And if we go here, it turns into a stream with objects. And then reduce. How many of you know reduce? OK, who of you hates using reduce? You can be honest. OK, not as many as I would have expected, because before I got familiar with it, I have to say myself, I was not really fond of this because it seemed very difficult to use. But there are some very useful use cases. I think it's also something that can be, in a way, used for cases that you normally should not use reduce for. Like, for example, you could implement your own sum function, which in most cases doesn't make sense, except in this example, where you can see we have a big decimal here. So usually in financial applications or in online shops or anything that uses prices or any kind of money or monetary value, you should use big decimal because double has some rounding inefficiencies or inaccuracies, I mean. But the disadvantage about big decimal is it doesn't really have a sum function, at least not that I'm aware of. Let me know if you know any. But what you would do normally is you would just create a big decimal 0, and then you would add up the total amount of different orders, for example, here, to get the total of all of the orders. And how you can do this with a stream is just by using this reduce operation. So first, what we do is we get the total amount from each of the orders that we have. And then we call reduce here, and we define the starting point here. So the starting point here is big decimal 0. And then here we define what kind of operation we want to perform. And here we see there is this add function that we want to use. So we just define big decimal add here. And then what this does is it goes through all of the elements and reduces them, hence the name, to one number in the end. So it adds all of the different big decimals to the 0. And then in the end, we will get the sum of all of them. So this is really a neat way to do this, especially if you need to do some filtering and so on. Then we have the sum function, which I assume probably a lot of you are familiar with. Just to show you a little bit of a twist here. So let's say we have a list of shapes. And then these could be circles, squares, whatever. So what I've seen in a lot of code bases is people do like a filter, and then they say s instance of circle. Here I already have a neat little trick for you. The way you can do this even nicer, in my opinion, is you could use what we have here. So you could say circle.class, and then : is instance. So this way, you can write it a bit shorter. You don't need to use a lambda arrow here. And it's still very explicit what we do. We filter out those where they are instance of circle. And then here we have this map operation where we cast it to a circle, because now we know it is a circle. And again, you can do this a bit easier here by saying map circle.class : cast. So this is equivalent to this one. But again, I feel like it's a bit nicer to write or easier to understand as well, because it makes it more explicit. I'm casting it here. And then, in this example here, you would, for example, call map, then get the radius of the circle, and you would reduce it down, which is one option. But again, I mentioned, why invent the wheel again when it already exists? So let's use sum here. Sum, it's just a one terminal operation that does the summing for you. You don't need to write a reduce operation. While this does work in this way, it is more difficult to understand. So really, I would recommend you to use reduce whenever you feel like there isn't any stock option to do this. So just use, if sum is available, this is more explicit, this is great, use it, it's usually better. And you can see also here we use map to double to get a list of stream of doubles. We don't need to do this here because reduce can also work on objects, for example. but some requires you to have an int, a double, or a long in this case, because those are the types it can sum up. Then who of you knows about parallel stream? Already quite a lot. So those of you that know it already, it's probably not that interesting, but those of you who don't know, this is kind of probably magic, because what parallel stream allows you to do is you just replace .stream with .parallel stream, and then instantly your code becomes multi-threaded, which is amazing. I mean, the cool thing about this really is, and shows me why it really makes sense to use streams in a lot of cases, is even if you think maybe your application won't have the need to use multi-threading, maybe it becomes something that you want to do in the future. And every one of you who has written multi-threaded code knows how painful it is. And usually you want to avoid that. So if you write your code with streams in the first place, you can avoid having to rewrite it later to either use streams later, so you can use parallel stream, or to write it with multi-threading in mind. So just here, pay attention. So you might think, oh, now I know parallel stream, it does it multi-threaded, so let me just use it everywhere, right? But this is the wrong way of thinking, because, of course, as soon as you're distributing different tasks to different threads, then you're introducing some kind of overhead, which means that with small data, it could be even slower than just using a regular stream. So make sure you use a parallel stream really in cases where you have an operation that is slow. Just to show you an example, so here I have a demo where you have a list of numbers from 1 to 100,000. Again, we are using range closed here. And then we put them into a list. And then here you can simply call parallel stream. You can perform some heavy computation, like in this case, get the square root. And then you can, for example, do the sum here. And this is really a lot faster. If you want to know how fast it is, there's actually a tool in Java which is called JMH, which allows you to do micro-benchmarking. It would be a good case to test in this example, for example, how much faster it is compared to something else. I also have a talk on that. In case you're interested, let me know. I can send you the link. Yeah. And let's go to sorted. I mean, I mentioned it already a few times before. So let's say we have some of our favorite products that we want to get. We want to find out which ones are in stock. Then we could do this. And I mean, this is really similar to the other examples we've seen earlier, so I'm not going to get into it into much detail. But you can see here we filter first, then we sort it, and we get the name of each product and put it into a list. Let's go to limit. Who of you knows limit? OK. Not as many people as I would have expected. That's interesting. So first, to show you a basic example how you would do this without limit, which I've seen before also in codebases, is you would just do a sort. And then let's say we want here to get the top 3 rated products that we have. And then we get the rating, reverse it again to have the one with the highest rating at the top of the list. And then we collect it to a list. And then we check, do we have actually 3 elements? Because maybe we have less than 3. Then we get a sublist. And then else we get the sorted products. This is, by the way, not 100% equivalent to this one. I just wanted to keep it a bit short. Obviously, if you have, let's say, 2 elements, this would just give you, it would just give you back the previous list that we have here, while this will create a new list in any case. But we already do this here, so it is kind of the same. But here, what you can do is, instead of going with collect here and then writing this ternary or this if again, you can do this much easier by just calling limit here with 3. And then you can collect it. And this will just give you the top 3 elements that you have in the list. So again, you can see this is a bit shorter. And also, it makes it a lot more explicit and is easier to write. You don't need to remember to write this sublist thing here and have this if check, which probably you could forget very easily. And then there's count. I already briefly mentioned it earlier. This allows you to, instead of what I also see being done sometimes, is collecting to a list and then calling size here to get the size, where it's much easier if you, instead of doing collect, you just call count. And then by calling count, you will just get the count. And this, again, is also in some cases quicker than this one, because in this approach, it needs to collect really the items into a list, while here you will just count the amount of elements that you have, and you don't need to build a list of the objects and things like this. So this is also a better approach in that way, but it's also more readable, so I don't see why you shouldn't do it that way. Then distinct. Who of you knows distinct? OK, that's more than expected, around half of the people. So distinct is a way of getting only the unique elements. This is something where if you want to do it, especially if you want to preserve the order, like in this example, we want to get all of the discount codes that we are using in orders, but we want to have them alphabetically sorted, for example. This is a bit more difficult. So with a hash set, you would first collect everything into a hash set. Then you would create a new list from that set, and then you would sort it with collections.sort. This is also slower than the approach that we take with streams. Here we can simply call a map to get the discount code from the orders. And then we call distinct, which filters out any duplicates that we have. Then we call sorted to sorted. And then with toList, we then get the list. By the way, toList, in case you haven't heard of this feature before, probably you're more used to seeing .collect, collectors toList. It's a feature that was newly introduced in Java 16. So I'm curious, so who of you uses, let's say, below Java 8 at work? Nobody, that's great. Oh, maybe one person. Thank you for your honesty. Who of you uses Java 8 at work? OK, so more people, so like 4, 5, 6. OK, interesting. Yeah, I mean, this is why I always say those things, because people underestimate how much it is still used. So if you use Java 17. OK, so that's most of you. That's great. Perfect. Nice. Great. So yeah, so toList is a feature you can use if you want to have immutable lists. So those lists cannot be modified. So in most cases, actually, this is kind of a drop-in replacement, but just be careful. Don't go just replacing it in everywhere in your code base. All of the cases where you have collectors toList with just toList, because probably some part of your code will break. I mean, if you have a good test coverage, then for sure go ahead. But just to let you know, it seems like it's the same, but it's not. Really, this gives you an unmodifiable list, while the regular collectors toList gives you a modifiable list. So, but anyways, it makes sense to use unmodifiable lists, because then you can make sure that it's not tampered with, in a way that you don't expect to. So yeah, then let's go to toSet. Kind of this is the equivalent of distinct, but if you don't care about the order that much, where instead of calling toList, you can simply call toSet. And then this way, you can simply get all of the elements into a set and get the unique ones. Here, you don't need to call distinct, because, of course, the set already takes care of that for us. Then, who of you knows tomap? OK, a lot of you. Who of you knows the difference between tomap, grouping by, and mapping? OK, 3, 4 people. And that's something that I noticed people always struggle about. And that's also why I wanted to show you this, because I feel like it's, once you have it understood, it's much easier to understand. So to map, you kind of have to think of it. It's very similar to grouping by. Mapping is actually quite a bit different. So think of tomap and grouping by, where if you use tomap, maps one key to exactly one value. So this is if you want to get a map in Java where it is really just one key, one value. You map those two together. And this is mostly when your keys are unique. But you can also specify an optional third parameter where you can define how you want to handle cases where a key maps to multiple values. I'm curious, who of you knew about this fact? Raise your hand. OK, so 5, 6 people. That's great to know. OK, so you learned something new today. So, and then if you don't provide a third parameter, if there is a key that is not unique, then you will get an exception by default. So this could be also a desired behavior, of course. I had cases at work where it was desirable to have an exception in these cases. But here's, for example, a basic way. I'm not going to run through it in too much detail. You can look at the code on your own. You see, it's very messy. It's very annoying. And you'll be shocked to see how easy it is to do it with just using tomap. So, and just keep in mind, it seems long, but it's just because I've broken it down into multiple lines here. So what we do is essentially we call a stream on the products. So what we want to do is, by the way, here we want to get the cheapest product per category. So we want to have a map where we have the categories and then get the cheapest product as a value. So here what you do is we do a stream on the products that we have. We call collect, then collectors to map. Then we define what kind of function is needed to get the key from the object that you have. So in this case, we want to get the category. And then we can say what kind of function we want to get the value. So in this case, we want to get the product by itself. But for example, if you wanted to get the product name, you could do product, : get name here. And then you would get the name as the value in this case. And by the way, in case you didn't know about function identity before, this is the same as just writing product, and then a lambda arrow, and then product again. I'm curious, how many of you were familiar with that? OK, around half, I would say. Yeah, so just so you know, so this is the same as just writing it this way. I think it's just a bit nicer to write it. And then, for example, we could write a binary operator min by, and then this way we can say we want to have the minimum here. This is the third parameter. Remember I mentioned this is the third parameter where you can define if there are multiple ones that have the same key, where we say here, if there are multiple values with the same key, then just take the smallest one and you compare it by the price in this case. So you see, it's quite straightforward, especially if you don't want to have this part. It becomes even simpler. And this saves you a lot of headache when writing it this way. And then grouping by, as I mentioned, it's very similar to tomap. But you use this when you want to have keys mapped to multiple kinds of values. Like let's say, for example, we want a list of orders which is grouped by the customer. So for example, you could also use this to use it as a starting point to get, for example, the amount of average orders per customer or things like this. Where in the traditional approach, it would be a bit more difficult to do. Maybe something to point out here is that also I don't see people use a lot is compute if absent, which is a feature that you can use where you can say, for example, I want to add the customer ID, and if it doesn't exist, this key, then it creates a new array list and then adds to it, and or not adds to it, it creates it and gives it to you. And then with add, you can add to it, to this list that you get here as a result of compute if absent. And then this way it's a bit shorter than having to write an if condition and so on. And then in the more simple approaches, you can see just 2 lines compared to, I don't know how many those are. It's much easier. You just write orders.stream, collectors grouping by, and then you define just what kind of key you want to group by. Like in this example, let's say we want to have the customer ID. So then we would get from this list of orders a list which is a map which is separated by the key which has the customer. And then you would have the list of orders of that customer that's associated with it. Good, so then let's go to the last one, collectors.mapping. Just remember, this is something you should not think about using at first when you are writing a stream, I would say. Because most of the time, this is something you really use in conjunction with, for example, grouping by or partitioning by. So if you have one of those, then this is something I would recommend depending on what you want to do. Like in this example, if you want to group the product names by the category, so what we want to have in the end is we want to have a category as the string and then a list of the product names. What you can do is in grouping by, for example, to combine it with the one we have just seen earlier, we can call product get category to define the key. And in grouping by, you can also define a second parameter where you can define how the value should be built. And in this case, for example, if we want to have a list, we can use collectors.mapping. And this way, we can define that we want to have the name and then put this into a list. And then this way, we can have a string which maps to a list of strings which has a different attribute. We couldn't call here .map in between collect and the stream. Because if you would map, for example, here to the category, we would only have a stream of the categories themselves, which would not allow us to then get the product name, which is why mapping makes sense. So kind of in cases where you have those struggles where you notice, oh, I can't call map here because then I can't access the name, and but I want to have a map. I want to use grouping by. Then remember, you can use mapping to achieve exactly this result. So this is really something that you should remember to use as soon as you have a situation where you turn into it. So just remember, grouping by and toMap are the ones that you should pay attention to. toMap is the one you use for if you want to have a one-to-one mapping. If you want to have multiple values, then you use grouping by. And then mapping if you turn into a situation like this. So I'm running a bit out of time, but I think we have time for one or two more. So let's go to collectors counting. How many of you didn't know collectors counting? OK, not that many. So just to show you how you would do this with a regular for loop, here we would have two nested for loops again, which we have here as the flat map. And then here we put in the item by the name. And then we kind of count how many times something appears. And you see this is kind of clunky here. So we say we get the default of 0 if we don't have an entry in the map yet. And else we just get the value, and we add 1 to it, and we put it into the map again. So this is a bit cumbersome. So in this case, we are counting the number of times an item was sold by the item name. This could be an interesting statistic to know. And then here, what you could do with a stream would be to just do a flat map first to get access to the items. And then you can combine also collectors counting with collectors.grouping by. And in this case, we say we want to have as the key the name, and as the value, we want to have the count of each of the elements. So you see, this is again one of those that you mostly use to combine with other collectors. Usually, if you would want to just collect it at this level, if you want to at this level use collectors.counting, then you would typically just use count. So this is just something that you can use, for example, in the grouping by or partitioning by or something like that. So since I'm running a bit out of time, just to show you, I have a lot more examples in here. And if you scan the QR code, you get access to all of those examples. You can look at them yourself, have a look at them, and see maybe what you're missing out, what could be an interesting feature to learn about that is existing for Java streams. And if there's one recommendation I can make is, maybe if you have some time, look at the collectors Java doc and see what kind of collectors are there. Because there are many useful collectors that you can make use of that could be very valuable to you. I didn't mention all of them, but I mentioned the most important ones, or basically all of them. So yeah, just to get back to here, you have the QR code again. And I hope you enjoyed it. We don't have time, unfortunately, for the questions, but you can just approach me afterwards. And also, I brought some Swiss chocolate and some stickers. So if you want some, then just approach me. Thank you so much for your attendance.